Hello, and welcome to the second episode in this series of videos where, as a GCSE and A-level maths and physics tutor, 6 years on from my GCSEs, I go and look at some past papers and give them my best go. So, in the previous video, or two videos, I did paper one higher, which was non-calculator from 2023 on the Edexcel specification. Um, did okay. It's worth going back and having a look, I think. And now I'm doing paper two, which is calculator allowed. Now I have a calculator with me, obviously, but I feel as though for the best viewing experience, it's best if I'm doing calculations on screen. So the Windows calculator is probably a little bit limited, or I'm not that familiar with it, and so I feel as though the best way to recreate exam conditions is to use Wolfram Alpha. Obviously, Wolfram Alpha is more advanced than a calculator you would have in GCSE, but I'm going to intentionally limit my use of it to basically just the capabilities of a normal GCSE calculator. So Wolfram Alpha, for example, can solve quadratic equations. I obviously won't be doing that. I will be solving them manually if that comes up on this paper. I'm not sure. So this paper, like the previous one, an hour and a half time limit, which I've got a timer set up, and a total mark of 80. So about 1 minute per mark, ideally. Last paper I finished in about an hour and 20 minutes, just because I was commentating over it. I think slowed me down notably, and I'll be doing the same here. Hopefully, I should be able to finish this within the hour and a half while talking through what I'm doing. So yeah, without further ado, I will begin the countdown. Has that started? Yep, okay. And then I will start the paper. So, expand and simplify. Just start with 3, 2y minus 5. 3 times 2y minus 5 plus 7 times y plus 2. So immediately just expand out those brackets. That's going to become 6y minus 15 plus 7y plus 14. We just collect our like terms. 6y plus 7y is 13y, and minus 15 plus 14 gets us minus 1. And just as a sort of point, I'm going to put my final answers in brackets so that you can sort of see. Yeah, let's make it clear, basically, especially for marking later on. Factorize fully, 6x squared plus 15x. I tried sort of doing headers for the questions, but I'm not going to do that this video, just because I think it's a waste of time, and also you can see it anyway. So we can immediately take a 3 out of both sides, and that would get us x squared. 2x squared plus 5x, and we can clearly as well take an x out of both terms, so we get 3x times 2x plus 5, and that is fully factorized. As far as I'm aware, we can't really factorize it anymore. Part C is make G the subject of the formula f plus 3g. F equals 3g plus 11. So we're just going to subtract 11 from both sides. We'll get 3g equals f minus 11, and then we'll divide both sides by 3. We'll get g equals f minus 11 divided by 3. I am using LaTeX, so I could make full fractions for these sorts of answers, but I find that it becomes a little bit too small to be well readable. So I'm going to just use sort of the forward slash notation for fractions throughout this paper. Okay, on to question 2. Karen is organising a party for charity. She spends £100 on food, £120 on a hall, and £80 on a DJ. So I think it's probably worth just going in immediately. Cost is 100 plus 120 plus 80, which is 300. Karen sells 54 tickets for the party. Each ticket costs £7.50. Work out the percentage profit Karen makes for the charity. So C for cost, 300, and then I will do E for earnings, 54 times 7.5, and I really don't actually need Wolfram Alpha to be able to do that, so I'm just going to use the calculator on here. 54 times by 7.5 is an earnings of £405. So then profit, like absolute, would be 405, would be E, I'll say E minus C, I'll try and define this well, would be 405 subtract 300, or 105. And then I'll say, like, a fractional profit would be equal to E minus C divided by costs, profit divided by costs, and that would be 105 divided by 300. And again, do not need Wolfram Alpha for this. 105 divided by 300, 0.35. And we can obviously very easily just say, okay, that's clearly 35%. And again, I will make sure that's in brackets as the final answer. Okay. I'll minimize that for now. Question 3. Andrew invests £4,500 in a savings account for 2 years. The account pays compound interest at a rate of 3.4% per year. Calculate how much Andrew has in his savings account at the end of 2 years. Very simple compound interest equation. Just like final equals initial times. I'll tell you what, I'll say something like S x for after x years. St. S as a function of t is equal to S naught in its initial savings multiplied by the interest rate to the power of the interest rate is a multiplier to the power of t, where t is time in years. So I can then do S naught 4,500 times our multiplier, because we have 3.4% per year, it's going to be 1.034, and we're taking that to the power of 2 years. This is where I think Wolfram Alpha is probably best, and this is something I could absolutely be doing on like a scientific calculator that I would have for a GCSE exam. So I think that's perfectly consistent with what I'm doing here. It's money, so we're going to have it to the nearest penny. So 4,811 pounds and 20 pence, and I'll put that again in brackets. Okay. Question 4 is to solve a 5x minus 14 equals 52 subtracts x. We just want to get all of our x's on the same side, all of our non-x's on the other side. So first of all, we'll add 14 to both sides. So that's 5x is equal to 66 minus x, and then we will add x to both sides. 6x equals 66, and then just divide both sides by 6, so x equals 11. And that's my final answer. So for some reason I keep missing the open bracket button, but there we go. Question 5. This is okay. Chris, Debbie, and Errol share some money, so I'll just write this down now. The ratio CDE is equal to 342. I'm sure it's no coincidence that the names start in C, D, and E. And we'll just say that Debbie, the money she gets, D, equals £120. Chris then gives some of his share to Debbie and some of his share to Errol. The money that Chris, Debbie, and Errol each have is now in the ratio. So I'll say something like C prime, D prime, E prime is equal to 2, 5, 3. So we can see that the number of units in this ratio has increased by 1, yeah? So we've gone from so 3, 4, and 2, 7, 9. Each unit in this ratio represents 1/9 of all the money. Now, 2, 5, and 3, each unit represents 1/10. So Debbie initially had £120, which was 4/9 of the total. So if I was to sort of say at the very start, let C plus D plus E equal T total money, then I would say that then this Debbie's share is, I will use the fraction here actually, 4/9 of the total. So I could just very easily say that total is equal to 9/4 multiplied by 120. I'm sure that maybe I could do that in my head, but again, why not use a calculator if you've got that ability? So 9 divided by 4 multiplied by 120 gives us that the total amount of money involved is £270. So then now at the end, CDE. So we need to find the amount of money that Errol, the change in Errol's money. So E is equal to 2/9 of that £270. Obviously, a ninth of 270 is 30, so we can just say quite easily that is £60 that he had initially. And then we can say that that means that E prime is equal to 3/10 of all of the money. And that's Errol's money after Chris has given it to him. Sorry, 3/10 T, I should say, which is equal to 3/10, so 27 times 3, 81. And so we can say, might say delta E as in the amount of money that Errol has gained is equal to 81 subtract 60, which is equal to 21. I will final answer that. And I'll put the pounds there. It's probably good advice if you're taking an exam like this to have that pounds involved the whole way, but maybe that will lose me marks, who knows. Question 6. The bearing of port B from port A is 147 degrees. Work out the bearing of port A from port B. So, bearings, if I remember correctly, are from the north. You then go clockwise in terms of where you go. So the bearing of port B from port A is 147 degrees. So I think it's probably best to just sort of think of a quick diagram. This is obviously something very available to you in an exam. So if we consider this line here represents north, and this is port A, so upwards being north. I'm just using this arrow as a sort of measuring stick, I suppose. Port B clearly is 147, so this is 180, this is 90, so it's somewhere in 135 would be the sort of 45-degree angle, so it's somewhere in there. It's close to that basically. And then B would be here. Again, we could put some kind of north measuring stick there, and you've measured that 147 degrees like that. So then from B, you have to go all the way around like this to get the bearing towards A. So if we consider that the 360-degree circle we're considering is is all this way around, the bearing from B to A is all of this, and then this is sort of left over out of 360. These lines are obviously parallel because they're both pointing north. So if this is 143, this angle here, hang on, this is 143 degrees, this angle here, then from the co-interior angles theorem, then this must be 180 subtract that. So this would be 37. Don't know why that took me so long, to be honest. And then obviously the remaining, this is just this angle here now is 360 subtract 37. So that would then be 323. I don't even know how I did that, to be honest. Okay, there we go. Okay, 323, and I'll put it there to represent sort of this whole bearing here. I will save this diagram, but I should also sort of write down a little bit of reasoning. It's important, just a little thing there, that 143 and 323. So with bearings, I don't have that much experience with them, but obviously it seems that it's not always you can just do one calculation maybe, and there we go. This is question 6. Co-interior angle between north lines, line AB, to north, is equal to 180 subtract 147, which is equal to 30. Did I say 33 when I did the working out? 37, because it's 143. Oh, it's 147 is the actual. Okay, well there we go. I don't know where I've got that from. So, just important to sort of redo this in that case. That's fine. Get rid of that. That's 147. That should be in black. I'll get rid of these two as well. Question is that my first mistake of the exam, or have I made one already? Who knows? This will be then 33, and then 360 subtract 33, 327 would be our bearing there. I will save that. 147 equals 33, and that should be degrees, of course. Bearing is then 33. You know, obviously the combination of the diagram and what I've written here should be enough when I come back to mark it. 327, hopefully. We'll see. And that's my final answer. I'll put that in there. There we go. Okay. Question number 7. Looking at a cylinder. The diagram shows an empty tank in the shape of a cylinder. We've got a 15 centimeter radius and a 43 centimeter height. Water flows into the tank at a rate of 0.47 liters per minute. Calculate the number of minutes it will take to completely fill the tank. Give your answer to the nearest minute. Right, so we're going to say time is going to be equal to the volume flow rate. And that's going to be V dot. Sorry, it's going to be the volume divided by the volume flow rate, which I'm going to say is V dot. V dot we know to be 0.47 liters per minute, but it's probably more useful if we have it in cubic centimeters. Now, a liter is equal to 1,000 cubic. A liter is equal to 1,000 milliliters, and a milliliter is equal to a cubic centimeter. So I say multiply that by 1,000 is 470 milliliters per minute. And then that just, I'll just say something like a milliliter is equal to a cubic centimeter. And then we could say V dot, the volume flow rate, is equal to 470 cubic centimeters per minute. Okay, then we'll continue. So V, we just get obviously from just using the equation for a cylinder, which is pi r squared h. Yes, pi r squared h, which is going to be equal to pi multiplied by 15 squared multiplied by 43. I can put this into to say in terms of pi? No. So this is all, again, something you could do almost identically in a scientific calculator. So again, this is perfectly fine in terms of the bounds of this exam. 3394.909 will probably be enough detail. Centimeters cubed is our volume. And then obviously we can just go back to our initial equation. T equals V divided by the volume flow rate. 30,394.909 divided by 470. And in the same way that actually I could do this in a calculator, I can take the number as it is in Wolfram Alpha and just divide by 470. So, like this. And I should, let's see what I get. 64.67. Yeah, that's enough detail, really, isn't it? And that's going to be to the nearest minute then 65 minutes. And again, I should put that in brackets. Does that seem quick, sort of, with this sort of maths reasonableness check? So I mean, I'm just thinking in terms of like, it's like a small, I don't even know actually how to describe what this would be. It's one of those tanks that you take if you go away in a caravan, I suppose. It's probably smaller than that, actually. Yeah, it probably is. 470 milliliters per minute is quite small, isn't it? It's one 500 ml bottle, an hour to do that. I can't think of anything that is this size, to be honest. What's that, 30 liters? Actually, yeah, one of the things you take on in a caravan is 40 liters. Would it take you an hour if you used 500 ml bottles? I can see that it might do, actually, yeah. So there's my amazing reasonableness check. Question number 8. A number x is written to two significant figures. The result is 1.9. Complete the error interval for x. This is one where I'm just going to sort of divine it, to be honest. I think it's going to be 1 mark for each thing you put on either side of x. And so I don't think I'll need to do much working out in terms of I can just write that. If you would have the actual number be 1.85, that would round up to 1.9. But 1.84999 recurring would round down to 1.8, and so it must be 1.85 is less than or equal to x. And then in terms of rounded up, 1.95 would round up to 2.0, so it must be smaller than that. But then 1.949 recurring would then round down to 1.9, so it's 1.95, but it's smaller than, not smaller than equal to, so it's in sync with what the symbols that are written here. I don't actually know what working out you're supposed to do in the exam to write down, I mean, except what I've just said out loud then, to be honest. Expand and simplify x plus 7, x minus 2, x plus 3. I'm going to use, I think it's an American terminology, FOIL, where you do first, multiply the firsts, multiply the outers, multiply the inners, and multiply the lasts to expand a set of brackets. So that's going to be first would give you x squared, outer would give you minus 2x, inner would give you plus 7x, and last would give you minus 14. And then obviously still multiply by x plus 3. And then important now to just collect like terms before I continue. Minus 2x plus 7x would give us plus 5x and then minus 14, and then obviously still multiply by x plus 3. And then now I'm just going to go through. So first times first, x cubed. I'm not going to use FOIL now because I've got a quadratic. Second times first is 5x squared. Third times first is minus 14x. And then first times second is plus 3x squared. Second times second is plus 15x. And third times second, 14 times 3, 42. So minus 42. And obviously just going to collect like terms because obviously it's expand and simplify. So that would be just the only x cubed term, that's fine. The 2x squared terms, 5x squared and 3x squared, add to 8x squared. It should be 2x terms, so that's minus 14x plus 15x gives you plus x, and then there's only one just numbers term, so that's minus 42 on the end, and that is my final answer. So there's the thing. So have a look at time. So we've got about 21 minutes gone so far. And I think I'm less than halfway into the paper as far as I can tell. Shakir has to complete 2 tests. You can either pass or fail each test. The probability that he will pass the first test is 0.87. If he passes the first test, the probability that he will pass the second test is 0.94. If he fails the first test, the probability will be that he passes the second test is 0.73. And it's asked me to complete the probability tree diagram. Let's just make sure we got those A, and I will complete this. So, and I think just to ensure full marks, I'll do a little bit of working out as well first. So, so I just need to do something like P fail first is equal to 1 minus P pass first. So that's obviously just the sum of all the probabilities of all possibilities is 1. So you can just do that quite easily there. Take away the known probability from 1, so that's 1 minus 0.87. And that is 0.13. And then we need to look at the probability that he will fail passes. If he fails, the possibility that he fails the first, sorry, fails the second given that, which is denoted by this vertical line in probability, he passes the first, is going to be equal to 1 minus the probability that he passes the second, given that he passes the first. And that is equal to 1 minus 0.94, and that is 0.06. And then final one we need to work out is the probability that he fails the second, given that he's failed the first. Yes. And that's equal to 1 minus the probability that he passes the second, given that he's failed the first. And we're given that probability I've mentioned there, so that's 1 minus 0.73, and then that is 0.27. So now I'm going to write down, I'm going to draw the completed diagram. Let's look at that. So we got this to be 0.13, just from 1 minus. Up here, this is so if he does pass, then to pass again is 0.94. Not in the right place though. And then that obviously gives us 0.06 down there. And then we had 0.73 to pass if he failed the first. And that gives us 0.27 to fail. And then we can just save as 10A. Okay. Work out the probability that Shakir passes at least one of the tests. So probability of passing more than one. That should be a subtext. What's it called? Not supertext. Subscript. Is equal to the probability that he passes both. So I'll say P1, P2. I'm using different notation and I don't care. Probability that he fails one, passes two. And the probability that he passes one and fails two. Did I not put a dollar sign at the start of that? Seems I didn't. Okay. And to find out these probabilities, I'll look at the diagram I just drawn actually. That was question 6. I'll look at question 10A. To find the probabilities, we can just multiply. And so that's going to be pass 1, pass 2 is 0.87 times 0.94. Fail 1, pass 2 is 0.13 times 0.73. And then pass 1, fail 2 is 0.87 times 0.06. And again, I could do this in a scientific calculator, so that's exactly how I'm going to do it now. In Wolfram Alpha, 0.87 times 0.94 plus 0.13 times 0.73 plus 0.87 times 0.06. Okay, and that is 0.9649. I'll check exactly how it wanted me to give the answer. Didn't specify a number of significant figures. So I think if it's not specified how many significant figures, you use the significant figures that you're given. So I was given 2 significant figures for all these answers, so I should say 0.96 to 2 significant figures is my final answer. Because that matches the number of significant figures that I was given, because there's probably some uncertainty on the data you're given, of course. 11. Got graph A, which looks like a linear. Graph B looks like a 1 over x or something similar. Graph C looks like a log. Also, it doesn't look a log, sorry, it looks like a square root. Now that I look down the graph D, looks like an x cubed, maybe? Something like that. Or an x squared, I'm not sure. Anyway, I would just asked to match the graph to the graph, to the graph to the equation, sorry. So, and it says fill out a table. I can obviously then insert a table, that sort of thing. So I'll say type of proportionality and graph. And let's have a look. So, x squared can only be graph D. So, say y equal y prop to x squared can only be graph D. And then y being proportional to x, as I said before, linear can just be graph A. Um, y being proportional to 1 over x has to be graph B. And then obviously left over, even if we, I mean, I said log, but obviously I can tell it's wrong. This is square root x. Sort of by process of elimination, but also just by looking at it, is graph C. This is sort of one we just have to know these shapes. To be honest, I don't really have that much reasoning behind it. I just sort of recognize the shapes, which is, I think, is part of the GCSE, to be honest. So, question 12. A, there we go. A has the coordinates 7, 13. B has the coordinates -3, 21. And C has the coordinates 15, 23. M is the midpoint of AB, and N is the midpoint of BC. Work out the distance between M and N. Give your answer correct to 1 decimal place. So here we can treat the X and Y axes completely independently, effectively. So if we're going to try and say M is the midpoint of, I'm just inventing notation completely here. This is not any standard notation as far as I'm aware. Midpoint of AB, we can just say, well, what's the average of the middle? Specifically the median, I suppose. I don't think that's any of those terms actually apply. The middle of the x-axis coordinates, the middle of the y-axis coordinates between the two. So, because so in between 7 and -3, that's a difference of 10. So it's going to be 5 away from either one. So that's going to be 2. And then, sorry, I should actually write this out formally because to make sure I don't lose any marks. So x of m is going to be equal to 7 -3 divided by 2. And that's equal to 7 minus 3 is 4, divided by 2 is 2, yeah. And then I can say y of m is going to be equal to 13 plus 21 divided by 2. 13 plus 21 is 34, divided by 2 is 17. So I can just say then m is going to be 17, which makes perfect sense. And then move on to n, which is the midpoint of b and c. And so I can say x of n is equal to -3 plus 15 divided by 2, which is minus 12 divided by 2, so 6. And y of n is equal to 21 plus 23 divided by 2. 21 plus 23, 44, divided by 2, 22. Makes perfect sense. I don't think I needed to calculate that, to be honest, but there we go. And that gives us n as 622. And so how can we find the distance between 2 points? We can use Pythagoras. So I can say something then like d and m is equal to the square root of 6 minus 2, so I should say 2 minus 6 squared, plus 17 minus 22 squared. And obviously, because it's squared, I'm going to end up getting all positive numbers anyway. I can do this just as I could on a calculator now. Square root, difference between 2 and 6, because again, positive or negative doesn't matter when you're going to square it, would be 4. And then 17 and 22, difference is 5. And so we get, was the distance to be given to 1 decimal place? The distance then is square root of 41, or 6.403. And I'm going to say then, put it in brackets for final answer, is approximately equal to 6.4, and that's to 1 decimal place. Oh, did not mean to put an extra sign in there. There we go. Okay. Question 13. Prove algebraically that 0.072 where the 7 and the 3 are recurring, can be written as 241 over 333. Don't know why I'm bad at reading numbers. 3,330. So x equals this. We're going to start off with that. Which is equal to, say approximately equal to, because it's not, yeah. So it's equal to 0.0723, and so on. And it's something to do with multiplying it by 100 or 1,000, if I remember correctly. Yeah, so it repeats. You have 3 digits is the repetition, so you need to do 10 to the power of 3. So I can say 1,000x is equal to... but they want me to, I can tell already that they want me to eventually get to 9,990, so it's something to do with the fact then. Therefore, 10x is equal to 0.723723, and 1,000x is equal to... Is it 1,000x? Because 1,000x is going to move it 3 places across. I want to line up the 723s such that I can eliminate it, and I don't know why I'm forcing myself to do it a weird way, to be honest. I'll just do it how I initially thought. Therefore, 1,000x, and I'll just sort of double check, like exactly what I'm thinking, 0.0723, which is enough detail, multiplied by 1,000, 72.3, yeah, 72.3, and then 723, ... So 999x, 1,000x subtract x is equal to 72.3723 minus minus 0.0723 ... I'll say 723, sort of, you get the message. So it's going to end up being 72.3, right? So 999x is equal to 72.3. And I think this is where we end up with this. So that means that 9,990x, here we go, is equal to 723. X is 723 divided by 9990. And I can divide both sides. Sorry, I can divide numerator and denominator of this fraction by 3. I think get 241. 24 times 3 is 72. 1 times 3 is 3. Simple. 3,330. And then because I've been asked to do that, this is a little bit of useful, what's the word? QED basically means I have shown what you've asked me to. It's a Latin phrase. Don't know why I'm writing it in a GCSE Maths paper, to be honest, but there we go. Question 14. Y is proportional to x squared, and we're told that y equals 3 when x equals 0.5. We're then told that x is inversely proportional to w, so that means that x is proportional to 1 over w. And we're told that x equals 2 when w equals 0.2. And we're asked w equals 2, y equals question mark, who knows. So we can start out with this x and y relationship. We can say actually more formally, not formally, just write it a different way. Y equals ax squared, some constant here. So we can plug in the values we've got. 3 equals a times 0.5 squared. A equals, can divide by 0.5 squared on both sides, 0.5 squared. And then, again, I could do this in a scientific calculator, so no problem doing it here. 3 divided by 0.5 squared. Constant proportionality of 12. And then we want to find out, so that just to sort of show the implications of that, y equals 12x squared. I shall put a therefore actually in that. And then we can continue. We can sort of do the same thing with y and w. We can, oh sorry, x and w. X equals b over w. Sub it in our figures. 2 equals b over 0.2. And therefore we can say b equals 2 times 0.2. That's quite obviously just 0.4. And we can say therefore x equals 0.4 over w. So now we try to put these two together. We're trying to establish a y-w relationship. We can just say therefore y equals 12 times 0.4 over w all squared. Yeah. We're trying to find y. Oh yes, we can literally just substitute it straight into this now. So y as a function of y when w equals 2 is 12 times 0.4 divided by 2 all squared. And we obviously could put this into a scientific calculator. So 12 times 0.4 divided by 2 all squared gets us y equals 0.48. Okay, on to 15. We're done, so it's 40 minutes into this, and question 15. I imagine we're getting there, probably not finished by any means, but there we go. The incomplete table and incomplete histogram give information about the times taken by some students to run a race. We've got time t seconds, and we've got intervals from 10 all the way to 26, and we've got frequency, we've got one missing. And then we've got an incomplete histogram there, and so we're going to be asked to complete both. Use the histogram to complete the table, use the table to complete the histogram. Yeah, okay. So for part A is to complete the table. So I'm just going to insert a table, and then it's going to be time t seconds and a frequency. So we just need to look at this first interval here, 10 to 12. So we don't have frequency density, but we can work out the frequency density. I'll use rho, frequency density. So 10, 12, oh sorry, 10x and then this and then 12. That work? Yeah. And we don't know. But then we can do excuse me, 12 less than t less than equal to 16 is 10. So frequency density is just frequency divided by bandwidth. Not bandwidth, it's called like class width or something, isn't it? I think it's class width. Class width is 4, therefore frequency density is 2.5. Because 10 divided by 4, 2.5. So this must be here, 10 to 16. Yep, 2.5. So these big divisions are 1 each, and each small division then is 0.1. Yeah, exactly. So this is 1.5 here, the frequency density. We can now fill that in. And then frequency. Okay, so frequency density of 1.5, class width of 2 gets us a frequency of 3. So that would be, the table obviously is already filled in there, so I don't need to, I have completed the table, haven't I? And then I can use that information to complete the histogram. So just have to do the 2 final classes, I think, yeah. Actually, it might be worth finishing that table. Let's just do that because, yeah, so I'll say 16 less than t less than equal to 19 was 15, and that's a frequency density. That's already been done for us, but I'll just frequency density of 5. 19 less than t less than equal to 21. Frequency of 9. The width of 3. Sorry, width of 2. Frequency density of 4.5. And then finally 21 less than t less than equal to 26. So it's a class width of 5. Frequency of 7. frequency density at 1.4. So I can now use this to fill in the histogram. So first thing I'll do is add some axis labels. I think just one per major subdivision will be enough, to be honest. I think if you're doing the exam, that's perfectly fine to get the marks. Not really given enough space, in my opinion, to inside this where it says frequency density for you to write that properly, but there we go. So we need to do the last two, don't we? So I'll use a thin grey line. Yeah, and then we're going to do 4.5, and that is 19 to 21. So 21 is clearly 2 boxes over, and it's 4.5, so that's up to there, and then we can go across. It's far too much being finicky there. And then 7, this is 21 to 26, this is 2 to the right of 25, and that goes up to 1.4, so that's, oh, this is what's good. I should have to zoom in a little bit here. So that was 1, 1.1, 1.2, 1.3, 1.4, there you go. Yeah, it should be one short of the 1.5 over there, which it is, so excellent. Okay, yeah, I think you should probably maybe scribble those in a little bit to fill them in, but I don't know, I'm going to consider that to be complete. And that was question 15B. Okay. Okay, question 15 continues. The histogram gives information about the times taken by 43 students to run a different race. Work out the estimate for the median of the times taken by these 43 students to run the race. So 43 students, so the median student, if it was 42 students, then halfway is 21. So the median student of 43 students is the 22nd. We have to just find out what the 22nd is. So let's have a look. So 10 to, I should zoom in a little bit here. This is going to be 11 and 12, isn't it? Yeah. 13, sorry, 13, 14, 15, yeah. 10 to 12. Frequency density is 2. So frequency is 4. And then 12 to 16. Don't know why I'm doing that bit in maths mode, I don't know. Frequency density is also 2, so the frequency is 8 because a class width of 4. So we're clearly not there yet. 16 to 20, class width again is 4. Frequency density now has increased to 4, so that means that the frequency is 16. Now I should say, sorry, cumulative frequency for this width. I should do a table here, obviously, but I'm a bit too far into this now. Cumulative frequency of 28 there. So the 22nd student is clearly in here, and he is, so median student is, he is 10/16ths through the 16 to 20 class. Because this ends at 12, so yeah, 10 more out of 16. Okay, so median time is equal to 10 over 16. So I would start with sort of the baseline. It's got to be bigger than 16 plus 10 over 16 multiplied by the class width of 4. Again, this is something we could do perfectly well in a scientific calculator, so no problem. And that is 18.5, and that seems very reasonable. Seconds should be put in a brackets around that, shouldn't I? Final answer. There we go. I'll zoom back out to make it a more pleasant experience. Question 16. ABCD is a trapezium. As we can see, we've got these side lengths and these angles, and we're told that AD is parallel to BC, and we're asked to calculate the area of the triangle BCD. So I'm going to use my standard method for these sorts of questions, which is just find out new pieces of information until you have the pieces of information you need. So what I should say first of all, actually, to make that a little bit more formal, is that the area of any triangle, any general triangle, is equal to half AB sine C. And that is where lowercase letters A and B are two sides, and C is the angle in between those two. So, for example, actually that sort of sets me up. If I can find this side length and this angle, then I've got it, right? So I need the angle CBD, and I need the side BD. I need those two dimensions. So we can start working on that, can't we? I'll sort of put this on this and I'll zoom in. Okay, so we can immediately work out this angle. So I can say angles in a triangle add to 180. So dBA is equal to 180 subtract BDA plus DAB. And that's going to be equal to 180 subtract 42 plus 112. And we can go over to our trusty scientific calculator. 180 sub 42 plus 112. And that is 26 degrees. And I'm not going to, I'll annotate the diagram because I feel like that's probably a useful thing to sort of, a useful habit to have, to keep this information where it needs to be. The length of this, I'm not going to degree sign because it's wasting time. The length of this one, we can use the the sine rule. Sine rule is that little a over sine big A is equal to little b over sine, I should be saying lowercase and uppercase obviously, but I'm a child, so like that. And we are looking for a lowercase, i.e. a side length, so we can actually say A is equal to B sine A over sine B. And in this case, this is going to be BD is equal to, so this side length here is equal to B, so it's going to be this known side length AB multiplied by sine of the angle opposite that side length. So that's 42 degrees, which is BDA, divided by sine B, which is opposite the side length B. Was that AB? Sine A is opposite A, so that should be 112, which is DAB, and then this should be the one opposite little b being 7.9, so that's 42 degrees there. Sorry, but I'm in this step, I'm labeling them all, aren't I? BDA. And then I can say, okay, so AB is 7.9 sine DAB is 112 divided by sine BDA, which is 42. It's useful to use these labels so that you can come back and sort of check your own work, and I can put this all now into my scientific calculator. And I'm going to make sure to do this in your exam as well. Specify that you're talking about degrees. Make sure that's the setting you've got on your calculator. 10.9467 is probably enough detail to get this worked out. That makes sense that it's smaller than this but bigger than this, so that's all fine. Okay, and then we're going to go back to a area of BCD. It's going to be equal to a half these. Oh, we didn't even work out this angle, did we? Actually, sorry. can we work out this angle? Oh no, yes we can. So AD and BC are parallel. So through the alternate angles theorem, or the Z angle theorem, I think it's alternate angle singular theorem, we know that ADB is equal to DBC. Therefore, DBC is equal to 42 degrees. Perfect. Okay, and I will add that to our diagram here. So we didn't actually. Did we need 26? We didn't need 26, which is annoying. So it shows the inefficiencies of the method, I suppose. BCD is going to be half AB sine c. So this is this length, this angle. So BC BD half AB sine DBC. And then we can just obviously sub in all of our, that we should use multiplication signs here to make sure that's very clear that it's, we're talking about different, these are individual side lengths, they're not, products of other variables. So BC, how have we not labeled that? I should have labeled that, shouldn't I? BC is 15.3, and then BD is 10.9467 dot 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 sine, and that was of that angle 42 degrees. And this number's already saved here, so I can click on that. Oh, it didn't really give much more detail, did it? And I'll say a half times 15.3 times y. That's enough detail to get a good answer. Sine of 42 degrees. That's going to be 56 point. How much detail did it want? 1 decimal place. 0 centimeters squared. 1 decimal place. Put it in brackets because it's the final answer. Is that reasonable? Yes, 15, 10. Yeah, I think that's all pretty reasonable. As far as I can tell, just as a quick evaluation. Question 17. A, show the equation. Yeah, I'll get onto that. So x cubed plus 2x minus 6 equals 0. Show that it has a solution between x equals 1 and x equals 2. All we're going to do is substitute in x equals 1 and x equals 2. So when x equals 1, we'll say 1 cubed plus 2 times 1 minus 6 is equal to 1 plus 2 minus 6, 3 minus 6 minus 3. When x equals 2, 2 cubed plus 2 times 1, oh sorry, 2 times 2 I should say, minus 6. Oh, it's not what I meant to do, like that. 8 plus 4 minus 6. 8 plus 4 is 12, minus 6 is positive 6. So we can see clearly that x equals 1, it's negative, x equals 2, I should write this down. When x 1, the output is negative. When x equals 2, the output is positive. So between x equals 1 and 2, there exists some x for which the function equals 0. I really see no, I don't really think I'd have to write much more there, to be honest, but there we go. We'll see how that ends up in the marks. Show the equation x cubed plus 2x minus 6 equals 0 can be rearranged to give what's been given there. So first step would be to put the 6 on the other side, because I clearly want to do that. So add 6 to both sides, and I would get x cubed plus 2x equals 6. And then I want to, yeah, just factorize this to x squared x plus 2 equals 6. And then just divide both sides by x plus 2. Did that wrong, didn't I? Sorry. X cubed. X squared plus 2. Yes, sorry. I can just take an x out of both sides, can't I? And that's x squared. Make sure to rub that out really well if you make a mess up like that in your exam. X equals 6 divided by x squared plus 2. That's my final answer. And because it's to sort of show that question, I'm going to write QED as in I have shown it. And then part C, starting with x naught equals 1.45. We're using iteration x n plus 1 equals 6 over x n squared plus 2 to find an estimate for the solution of this thing. So all we're going to do is just iterate terms out, right, using our calculator. So if you have a calculator, you can set this equation up and then just keep pressing equals. I'm going to have to sort of do this a bit more manually because of the way that I'm actually sat here doing it. So 6 over 1.45 squared plus 2. So I say x1 is equal to 1.4625. And then I can just sort of keep, I can use this, can't I? Oh. I only want it correct 4 decimal places, so as long as I have 4 decimal places, that's fine. I'll say 1.462523 to give some more detail. 1.462523. Oh, that's 24. And my x2 is 1.449635. So we're still not there. We're waiting until we get 2 answers in a row that are the same to 4 decimal places. This is how we're going to find our answer. 449635. 1.462900. x4. Just going to plug this back in now. 462900. That's 1.449249. x5, again, this is so much quicker if you're actually doing it on a calculator. This is where I actually maybe disadvantage myself. 449249. 463299. Oh, that should be 1 point, all that stuff, shouldn't it? 28 minutes left. I really hope we get towards the end of the paper, especially with this sort of, wasting my time a little bit, to be frank. 1.463299. 1.448840. Is this going to take a long time? It feels as though it might. 1.46. Is it even converging? It doesn't seem to be converging. These pairs seem to be getting further away. Right, I will leave this question. How much is the question? Well, I'll leave this 3-mark question. I will come back to it. I'll leave some question marks to show that I've not finished it. So I will come back. ABCD is a quadrilateral. E, F, G, and H are the midpoints of AB, BC, CD, and DA. AH is A is B, and DG is C. Prove using vectors that E, F, G, H is a parallelogram. So to show that it's a E, F, G, H, to show that it's a parallelogram, we have to show that 2 of the sides of that shape are parallel. Now, in terms of vectors, when we say how to say vectors are parallel, is that one vector is simply a multiple of the other because direction is not changed if you just multiply. Yeah, if you just multiply two by each other, that's not. So if you multiply a vector by a number, it doesn't change the direction, just the magnitude. So yeah, there you go. So we have to find definitions for EF, FG, GH, and HE. So EF is equal to let's just figure this out. So we need to go back to A, don't we? Can we get to so A8? We have AH, AE, and DG. Right. Okay. We can obviously use the fact that the midpoints is very useful. So what might be a useful thing to do straight away is we can say that AC is equal to AD plus DC, which is equal to 2AH plus 2DG, which is equal to 2A plus 2C. Okay, that's a useful thing because it is. We'll get there eventually. Get into B. Oh yeah, get into B. So I can say AB is equal to 2AE, which is equal to I should be putting arrows over the top of these, but that's honestly going to take way too long, so I'm not going to do that. 2B. Okay. So now, can I start to construct these things, for example? So because I have AB and I have AC, and because F is the midpoint of BC, if I do the average of AB and AC, I get AF. AF is equal to AB plus AC divided by 2, which is equal to AB is 2B, and AC is 2A plus 2C, and we're dividing that all by 2. So AF is just equal to A plus B plus C. I'll put it in nice alphabetical order. And then we know that AE is just B. Therefore, EF is equal to, so then EF is equal to, EF is equal to AE, sorry, it's AF minus AE, yeah, it's fine. Which is equal to AF being A plus B plus C, minus AE being B, so that's equal to A plus C. Okay, that's our first side figured out. And it feels like this question's taken me ages. So let's, how many questions is it? 18, 19, 20, 21. Okay, 21, we are almost there, we're not that far. Okay, but we do have to go back and do the iteration question. So, let's continue. So FG is equal to yeah, okay, so it's equal to, hang on, so AG, no. We have AF already, don't we? Yeah. Do we have AG? We need to figure out AG, that's what we need to do. AG is equal to AD plus DG. I feel like I've already done that before, but I don't know. AG is quite clearly 2AH, and DG we know to be C. 2A, so AH is A, so it's 2A plus C. We have AG, we have AF. So we can then write FG is equal to AG minus AF. Yeah. AG being 2A plus C, AF being A plus B plus C. So that's going to be A minus B. Yeah. So these two are clearly not parallel. And that's very obvious just from looking at them, isn't it? But it's going to be either HG and EF or EH and FG. So we'll just continue now. GH is equal to GA minus HA. And GA is equal to minus AG, which is equal to minus AG. So that's minus 2A minus C. HA is equal to minus, so we can say minus HA is equal to AH, which is equal to A. So GH is equal to, this feels like a lot of working out for this question, so I would skip this and come back to it. But I feel a bit too invested at this point, so minus 2A minus C plus A, which is equal to minus C minus A. There we go, we got it. So we could say GH. So first of all, we're going to say EF. We need to make two distinct points. EFGH are parallel. Sorry, EFGH is a four-sided shape by definition. And then we know that GH is equal to minus EF. So GH and EF are parallel. EFGH is therefore a quadrilateral with a set of parallel sides. So it is a quadrilateral. And then QED. And I think we actually have to prove that the other two, so the HE and FG aren't parallel, so I'll start really quick. So HE is equal to HA plus AE. HA is equal to minus AH. HE is equal to AE minus AH. We have AE somewhere, don't we? It's up here somewhere. AE is B. I've already been told that. B. And then AH, we've already been told, is A. Yeah, so perfectly fine. Yeah, so that's very clear now. So B minus A and A minus B. Yeah, sorry, it's two parallel sides, isn't it? Yeah, it's not quadrilateral. Sorry. And FG equals minus EH. So FG and EH are parallel with two pairs. So it's a parallelogram. Forgot my definitions there of different quadrilaterals. That was a very long proof. That feels like a lot for 4 marks. And we have 17 minutes left. Let's make them valuable. 19. This is about functions. This should be notably easier, hopefully. F of x is equal to 2x plus 3 squared. And g of x is equal to 2x minus 1. This should be fine, hopefully, he says. GF, we're trying to find GF of minus 3. If you've got a composite function, you do the one closest to the number first. So that's equal to G of F of minus 3. F of minus 3 is equal to 2 times minus 3 plus 3 all squared, which is equal to minus 6 plus 3 all squared, which is equal to minus 3 all squared, which is equal to 9. Therefore, GF of minus 3 is equal to G of 9, which is equal to 2 times 9 subtract 1, which is equal to 18 subtract 1, which is equal to 17, and that is my final answer for part A. It's going to be really annoying to mark that proof question 18. Once we find out the inverse of the function g. Didn't put a dollar sign at the start of that, annoying. Well, we have that we can start with replacing all the x's with y's. We can say x equals 2y minus 1. That's the trick of finding an inverse function. We can just now solve for y. So 2y equals, sorry, x equals 2g minus 1. Sorry, 2g of x. 2g of minus 1. Yeah, minus 1, yeah. That should be of x minus 1, like that. And then we can just solve. It's really simple actually now. X minus 1. Sorry, 2g to the minus 1. The inverse, of course, is equal to x plus 1. So then g, the inverse of g of x, is equal to x plus 1 divided by 2. Sorry, I should put that as final answer in brackets. Is that the end of question 19? Yes, it is. That's just a horrible, that's a horrible question, and that's really going to sap some of the 14 minutes. Even though it's not that hard, it's going to sap some of the 14 minutes, and this is where I would really start to lose the will to live if I was doing this exam. So, which I am doing this exam. I don't know why I'm saying if I was doing this exam. 14 divided by 3x plus 21, sorry, minus 21, plus x plus 4 divided by, and it's a whole fraction, 2x squared minus 6x minus 56 divided by 2x plus 3. Does that look anything remotely? Yeah, it's what it's supposed to look like, isn't it? First of all, let's tackle this really horrible looking thing here. So we'll say 2x squared minus 6x minus 56 divided by 2x plus 3. And we're going to try and just simplify that out. So we need to factorize the top, and we know that one of our things has to be 2x plus 3 to make it easy, as far as I can remember. 56 is a multiple of 3, isn't it? No, it's not. That's not very helpful. That's really not very helpful, actually. At all. That's really, really not very helpful. What I might do instead is say that this, if we're divided by this whole fraction, we're effectively multiplying by its reciprocal. So equals 14.3x minus 21 plus x plus 4 multiplied by 2x plus 3. It's a bit against common wisdom, I'd say, to now sort of make this fraction even more complicated, but it's what you have to do sometimes. 14, is it really wise to do that? I guess we can now try and see if we can pull out x plus 4, can't we? If 56 is divisible by 4, I'm convinced. It'd be 14, yeah, okay. So is equal to 14, there's the useful 14 there as well, actually, brilliant. Which might be useful, I don't know, let's see, x plus 4 2x plus 3. And that's divided by then x plus 4. The other one has to then be 2x, and it has to be minus 14. That doesn't make sense then. So that's plus 8x, that's minus 14x minus 6x. Yeah, perfect. Okay. Okay, and then 14 divided by 3x minus 21 plus, this then simplifies to 2x plus 3 divided by 2x minus 14. Now, this is where it might get a bit horrible. We have to get to the same, we have to get the common denominator, don't we? So we have to go 14, we have to multiply, cross multiply basically the factors, divided by 3x minus 21 multiplied by 2x minus 14 plus, this should all be bracketed better than it is. I should make that very clear. 3x minus 21 divided by 2x minus 14. 3x minus 21. Gonna get lost in the weeds, I can tell already. And that is 28 minus 14 times 14 is 196. That should be an x there. 3x minus 21, 2x minus 14, 2x plus 3, 3x minus 21, 2x minus 14, 3x minus 21. We have a common denominator. We can add these fractions together to make one horribly ugly fraction. 28x minus 196 plus 2x. Oh, there should be a division symbol there. That would have caused a lot of peril. 9 minutes to go. Let's keep our head cool. 2x plus 3, 3x minus 21, all divided by 2x plus 14, 3x minus 21. This is needlessly complicated mathematics that's being done here. And then we just need to basically expand the top brackets. So first 6x squared, outer minus 42x, inner plus 9x, last minus 63. And that's still all divided by 2x plus 14, 3x minus 21. And then we need to collect like terms. 6x squared minus, where are the x's? So we need to do 28 minus 42 plus 9. That gets us minus 5x. And then we need to do minus 196 minus 63. That's not going to be a nice number to work with, is it? But there we go, 259. And then 2x plus 14, 3x plus 21, minus 21, sorry. So this has to now factor into, we have to now be able to pull one of these out of one of these to make it work. I'm going to guess that it's 21 because I don't think, yeah, 259 is not a multiple of 14. Is it multiple of 21? Let's have a look. 21, so 259 divided by 21. Oh, that's a problem. That's a big, 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 big problem. Did I do the maths wrong here? 196 plus 63. No, I didn't say 53. 259. Yeah, that's correct there. 21, 14. Where's the mistake been made? Is 14 times 14 196? I think it is. Yeah. 14 times 2 is 28. Where's this 63 come from? That is 63 there, yeah, so I may have to leave that question there for now because I'm very, very, the time is now very limited. Let's just see what we can do with question 21. Vicky has a collection of medals. The Venn diagram gives information about the number of medals in her collection, where this really doesn't look that hard. Okay. So everything is all medals. A is English medals, B is gold medals, and we have these sets here. Vicky is going to take at random a medal from her collection. Given that the medal is gold, given that the medal is gold, so that's looking into set B. Given that it's gold, which is set B, probability of the medal is English is 2 out of 11. So x over 5x minus 3 is equal to 2/11ths of the total number of medals. I'll say m. Okay, this is really, if I'm thinking of this correctly, this should be completely fine. This should be no problem at all. Yes, I'm given that the medal is gold. No, it's not it's not 2/11ths of all the medals. It's just 2/11ths. It's getting very confident there. Can now say that 11x is equal to 2 times 5x minus 3. I can say that 11x is equal to, therefore, 10x minus 6. I can say then that x is equal to, subtract 10x from both sides, x is equal to minus 6. That doesn't make any sense. Have I flustered it all in the end? Maybe I have. Where have I gone wrong? Sorry, it's x over 6x plus 3, isn't it? Because you need to consider that is a total part of the thing too. 6x minus 3 is equal to 11x. Sorry, 11x then is equal to 12x minus 6. Yeah, and then that's minus x is equal to minus 6. So then x is equal to 6. And then we can say that the total number of medals is equal to 7x minus 11 plus x plus 5x minus 3 plus 34. Collect like terms. 7x plus x plus 5x is 13x. I'll go to the calculator. Minus 11 minus 3 plus 34 is equal to 20. And that is 13 times 6 plus 20 is a total of 98 medals, which is, it's not an unreasonable number of medals, is it? Right, it's the end of the question. Where did we go wrong with this here? It's divided, that's divided by. Did we do that correctly? Did we turn it into a multiplied by? I mean, look at all the bloody, look at all the brackets. What was that supposed to be, is the question. So we've seen already that it's not, 259 is obviously not a multiple of 14, and 21. Can we, if we multiply it by, if we multiply it by 2, this might be going down a really big rabbit hole here. If we can I give it in that format? I think I can. If I was to multiply the top by 2, then I would say 12x squared minus 10x minus 259 times 2 is 518. Can I pull 14 or 21 out of those? I mean, I sort of have to make this question work, don't I? 2x plus 14, 3x minus 21. Okay. Let's try, let's just try one. Let's just try that it's 2x plus 14. Can I get this to work now? It'd have to be 6x and then 518. That would have to make it minus 37. Okay, bloody hell, there we go. So 6x, 6 times 14 is 84, and minus 37 times 2 is minus 74, so that's nowhere near big enough. Has to be the other one. 3x minus 21. 2 minutes to go. This has actually added some tension to the whole situation. 4x. I mean, yeah, I have to just do this, don't I? 518 divided by 21 would be, it's not divisible by 21. That's a problem, isn't it? So I'll double check this again. 2x plus 14 would make this 6x minus 518 divided by 14. 37. Okay, so then 14 times 6 subtract 37 times 2 is 10. Okay, that's it. That's it. Right. 2x plus 14, 3x minus 21. You got the common factor of 2x plus 14, so you get 6x minus 37 divided by 3x minus 21. And that was what I was asked. I'll put all of that in brackets, and I'm going to drop the fattest QED of the entire paper right there. Okay, 1 minute 11 seconds left. Can we go back to the iteration question, wherever the hell that was? This was divergent. Why was that? Why was it divergent? If I go 6 over 1.45 squared plus 2, it does give me that. I actually might have to dig out my scientific calculator and just spam it until I converge. I've got 47 seconds left on the clock. Is this going to be a buzzer beater, as the Americans call it? 1.45 squared plus 2, and then, yep, and then do that, and then say, put answer in the... Okay, I'm just going to spam it and see if I get anywhere. I'm not seeming to get anywhere. We've got 20 seconds left. It's just divergent, to be honest, folks. So, am I using the right iterative series? Yeah, I am. So use it twice. I missed use it twice, and it's too late. And so there we go. There we go. I'm not going to be able to put it anywhere. Moral of the story is read the question correctly. I know that I will have only gotten 2 marks at best. Probably only 1, to be honest. Use it twice because it diverges, that series. So that's the end of this video. Thank you very much for watching. The next video will be me marking this paper and seeing how I did. So see you then.